let's have a look at calculus. So y equal x ln bracket x to the power of 3. Okay, so this is logarithmic function, but not only. What I have here is a multiplication sign. So what do we need to do with that information? We have to find the value of y, so this number, when x is 2. So that's simple enough. We are replacing x with 2, so therefore y will equal 2 multiplied by ln. By the way, ln means what? Log of e, isn't it? And then again, instead of x here, we put 2 to the power of 3. We put all of that in our calculator, and to 4 decimal place, we should get 4.1589. Now, let's have a look at part 2. So it's saying find what? A derivative, isn't it, of our function. So our function, again, is y equal x ln bracket x to the power of 3. So what we have here is what? Two functions multiplied by each other. So that's my u function, that's my v function. So what are we going to do here? We're going to apply what? A product rule. Yeah, so that's our product rule. Let's take that. Now, when I'm doing either product rule or quotient rule, I like to write everything out so that I don't mix up stuff. So my u function is x, my v function ln x to the power of 3, and then derivative of my first function. So derivative will be what? This is just x with no power, therefore the number that stands beside x will be 1. And then we need a derivative of the second function. Now, here is a little bit more complex, because if I go to my table and I look at the formula is telling me when I have ln x, it just changes into 1 over and then x here. So in theory, the way it should work should be 1 over and then my x to the power of 3, because that's what I have. However, because I have more than just x to the power of just x, but I have x to the power of 3, I have to multiply by the bracket here, by the derivative of this bracket. So basically that is a chain rule applied, because I have a function within a function, because x to the power of 3 in itself, it is a function, a very simple cubic function. So that's the reason why I have to multiply by the derivative of the bracket. That's how you know. Usually, the way you will know, because very often students ask me, how do I know that it's a chain rule? When your function have a bracket in it, then that's usually an indication of a function within a function. So what is a derivative of x to the power of 3? 3 goes in front, and then power minus 1, so 2. That's our very first formula. So when I have x to the power of n, n goes to the front, and then that power minus 1. So that means I'm multiplying that by 3x to the power of 2. Now, we can simplify that a little bit further. Let me write it out so that you can see it. X to the power of 3, that is x multiplied by x, isn't it? And then here I have multiply, and here I have 3 multiplied by x, and everything over 1. Because every number can be written as a fraction over 1. So I can clearly see that those x's will simplify out, isn't it? Because x by x is 1, x by x is 1. So really what I have here, I have 3 on top of the fraction, because 1 multiplied by 3 is 3, and x multiplied by 1 is x. So that's what is my second derivative. Now, let's get our product rule and let's put it all together to create a derivative. So first we take function u. Function u is x, so it will be x multiply. Then the derivative of our second function, so 3 over x, plus, and then the v function, which is ln x to the power of 3, and then multiply by the derivative of the first function, which is just 1. And now basically we have to work our numbers a little bit. As well, they are telling us to give an answer in the form a plus b ln x. Okay, so let's see whether we can get there. So here, what do I have? Again, if you're a little bit, oops, that's not what I wanted to do. If you're a little bit confused when it comes to fraction, write everything as a fraction, because then you can clearly see this x divided by this x is 1. So therefore, I am left only with 3 here, which is fine because that's what I need. I need a, and a is the number, and they are telling me where a and b belong to n. And if in the exam you don't remember what n is about, page 23 in your table here reminds you about those sets. So you can see n whole positive numbers. So yes, that's a whole positive number, correct. Then on the other side, I have ln x to the power of 3. But I'm saying, okay, I have ln, they have ln. However, the difference is here. They have only x, I have x to the power of 3. They have a number here in front of ln. I don't have a number. I'm saying, can I change that? Don't forget that ln is log of e. So what do? I go to the table and I look for the formulas with logs so that can I write that in a different manner? So here we have a formula that is reflective of our situation, isn't it? Because here, that's what we have. That's my base here. So that will be my a. Then I have x, like actually the way they have x. And then I have power of 3. So they have this power of q here, and they're saying you can write it in the front. So that means that 3 can be written in the front. So that will be 3 log ex. And there it is. We have written, oh, let's actually change that to ln so that it is the way they want. So yes, indeed, we have written in the form that they were looking for, fulfilling the condition of value a and b. Again, nice example for integration to practice, not very complex.